Okay, you guys, let's tackle this airframe electrical system. We're going to do 45 questions in this video, and let's jump straight into it. In a generator, what eliminates any possible sparking to the brush guides caused by the movement of the brush within the holder? A, the brush pigtail. B, brush spring tension. Or C, undercutting the mica on the commutator. So in a generator, what eliminates any possible sparking to the brush guides caused by the movement of the brushes within the holder? The brush pigtail. The brush pigtail eliminates any possible sparking between the brush and the brush guide. All the current is carried from the brush into the holder through the pigtail rather than through the sliding contact made between the brush and the brush guide. So I'm going to jot down the brush and the brush pigtail under, let's do visuals. Okay, so next question. Aluminum wire must be stripped very carefully because A, high resistance will develop in stripping nicks. B, stripping nicks can cause short circuits. Or C, individual strands will break easily after being nicked. So aluminum wires must be stripped very carefully because individual strands will break easily after being nicked. Next question. If any one generator in a 24-volt DC system shows low voltage, the most likely cause is A, an out-of-adjustment voltage regulator. B, shorted or grounded wiring. Or C, a defective reverse current cutout relay. So if any one generator in a 24-volt DC system shows low voltage, the most likely cause is an out-of-adjustment voltage regulator. And I do want to write down voltage regulator. You can write down voltage regulator. Next question. What type of instrument is used for measuring very high values of resistance? A, megometer. B, shunt type ohmmeter. Or C, multimeter. So what type of instrument is used for measuring very high values of resistance? A megometer. A megometer is a special type of ohm meter used to measure very high values of resistance. Many megometers have their own high voltage power supply built into them. Next question. In aircraft electrical systems, automatic reset circuit breakers, A, should not be used as a circuit protector device. B, are useful where only temporary overloads are normally encountered. Or C, must be used in all circuits essential to safe operation of the aircraft. So, in aircraft electrical systems, automatic reset circuit breakers should not be used as a circuit protective device. 14 CFR Part 23 states that each resettable circuit protective device must be so designed that a manual operation is required to restore service after tripping. Next question. During inspection of an anti-collision light installation for condition and proper operation, it should be determined that A, electrical or mechanical interconnections are provided so that the anti-collision light will operate at all times, that the position light switch is in the on position. B. An appropriately rated fuse is in position at the light to protect the connecting wiring against electrical faults. Or C. The anti-collision light can be operated independently of the position lights. So, during inspection of an anti-collision light installation for condition and proper operation, it should be determined that the anti-collision light can be operated independently of the position lights. Next question. A series wound DC electric motor will normally require A. More current at high RPM than at low RPM. B. Approximately the same current throughout its operating range of speed. Or C. More current at low RPM than at high RPM. So a series wound DC electric motor will normally require more current at low RPM than at high RPM. A series wound DC motor produces an extremely high starting torque. It uses a large amount of current when it first starts to rotate and when it is operating at slow speeds. The current drops off as the armature speed and the counter EMF builds up. Okay, next question. The method most often used in overcoming the effect of armature reaction is through the use of A. Interpoles, B. Shaded poles, or C. Drum wound armatures in combination with a negatively connected series field. So the method most often used in overcoming the effect of armature reaction is through the use of interpoles. Interpoles are used in a large compound wound DC generators to overcome the effect of armature reaction. If armature reaction is not corrected, it will cause the brushes to arc under certain load conditions. Next question. Which of the following statements is true? An AC Selson system is a widely used electrical method of indicating a remote mechanical movement or position. B. A resistance type indicating system is an electrical system used for transmitting information from one point to another. Or C. A synchro type indicating system is an electrical system used for transmitting information from one point to another. So which of the following statements are true? A synchro type indicating system is an electrical system used for transmitting information from one point to another. A synchro type indicating system is an electrical system used for transmitting information from one point to another. A DC Selson system is a widely used electrical method of indicating a remote mechanical movement or position. Next question. To help minimize radio interference, a capacitor will largely eliminate and provide a steady direct current if the capacitor is connected to the generator in A. Parallel, B. Series, or C. Series parallel. So to help minimize radio interference, a capacitor will largely eliminate and provide a steady direct current if the capacitor is connected to the generator in parallel. The output of a DC generator normally has some AC hash or noise caused by brush arcing superimposed on it. This AC can cause radio interference, and it may be removed by connecting a capacitor between the armature and ground in parallel with the armature windings. The AC passes to the ground through the low impedance path provided by the capacitor. So we're also going to write down armature. We are going to write down windings. And arcing. Next question. What is the most accurate type of frequency measuring instrument? A. Integrated circuit chip having a clock circuit. B. Electrodynamometers using electromagnetic fields. Or C. Electromagnets using one permanent magnet. So, what is the most accurate type of frequency measuring instrument? Integrated circuit chip having a clock circuit. Going to go to instruments. And we're going to write down integrated circuit chip. Next question. What is an important factor in selecting aircraft fuses? A. The current exceeds the predetermined value. B. The voltage rating should be lower than the maximum circuit voltage. Or C. Capacity matches the needs of the circuit. So what is an important factor in selecting aircraft fuses? Capacity matches the needs of the circuit. It is important when aircraft fuses are selected that all the circuit ratings or current ratings are appropriate for the circuit protection required. The aircraft service manual specifies the current ratings to be used. Next question. Refer to figure 18. Which of the batteries are connected together incorrectly? We're going to go with 2. Oh, no. 3. The batteries in 1 are connected correctly in series circuit. The batteries in 2 are connected correctly in parallel circuit. The batteries in 3 are connected incorrectly in parallel circuit. The polarity of the center battery is reversed, and it will act as a short circuit across the other 2 batteries. Next question. Which of the following is most likely to cause thermal runaway in a nickel-cadmium battery? A. A high internal resistance condition. B. Excessive current draw from the battery. Or C. Constant current charging of the battery to more than 100% of its capacity. So, which of the following is most likely to cause thermal runaway in a nickel-cadmium battery? Excessive current draw from the battery. Thermal runaway of a nickel-cadmium battery occurs when some of the cells become excessively hot. The heat lowers both the voltage and the resistance, so the cells can accept a high rate of charging current. This high current produces more heat and the battery can destroy itself. The temperature rise that triggers the thermal problems can come from heat generated by a fast discharge, from high ambient pressure, or from a breakdown of separator material. Next question. Which motor would be most likely to have an armature brake? A. A starter motor. B. Landing light retraction motor. or C, inverter drive motor. So which motor would be most likely to have an armature brake? A landing light retraction motor. A landing light retraction motor is the most likely of all motors listed here to have armature brake. The brake causes the armature to stop turning as soon as the switch is released. So we are going to write starter motor. Landing light, retract, and inverter drive. Next question. The voltage output of an alternator may be regulated by controlling the A, speed of the alternator, B, voltage output of the DC exciter, or C, resistance of the rotor windings. So the voltage output of an alternator may be regulated by controlling the voltage output of the exciter. The voltage output of an AC alternator is determined by the amount of current flowing in its exciter field. The alternator output voltage may be controlled by varying the output voltage of the DC exciter. We are going to write down the AC alternator. And here next question. To what depth is the mica insulation between the commutator bars of a DC generator undercut? A, 1/2 the width of the mica, B, equal to twice the width of the mica, or C, equal to the width of the mica. It could be mica, but we're going to stick with mica today. To what depth is the mica insulation between the commutator bars of a DC generator undercut? C, equal to the width of the mica. When a DC generator is overhauled, the commutator is turned on a lathe until it is perfectly round and smooth. After the commutator is turned, the mica separators between the commutator bars are undercut to approximately the width of the mica, or somewhere in the neighborhood of 2/100 of an inch. Next question. Aircraft electrical junction boxes located in a fire zone are usually constructed of A, aluminum sheets, B, carbon steel, or C, stainless steel. Aircraft electrical junction boxes located in a fire zone are usually constructed of stainless steel. A battery generator system provides direct current. On installations requiring alternating current from the battery generator system, it is necessary to have A, a transformer, B, an inverter, or C, a variable resistor between the battery and a generator. So, a battery generator system provides direct current. On installations requiring alternating current from a battery generator system, it is necessary to have B, an inverter. An inverter is a device that converts direct current into alternating current. Next question. A CSD unit drives a generator through the use of A, a synchronous electric motor, B, an indefinitely variable mechanical gearing system, or C, a variable hydraulic pump and hydraulic motor. So a CSD unit drives a generator through the use of a variable hydraulic pump and hydraulic motor. AC generator speed is held constant as the engine speed varies by a CSD unit. A variable delivery hydraulic pump supplies fluid to the hydraulic motor. The ratio of the speed between the input and output of the CSD is varied to maintain a constant generator speed by controlling the pressure of the fluid that is delivered to the motor. What is the appropriate method for installing pre-insulated terminal lugs and splices to electric wires? A. Using a crimping tool to secure the terminal lug. B. Soldering the terminal lug to the end of the wire. Or C. Soldering the exposed wire prior to crimping the terminal lug. So what is the appropriate method for installing pre-insulated terminal lugs and splices to electrical wires? Using a crimping tool and secure the terminal lug. Crimp terminals on an aircraft electrical wire transmit the tension and vibration loads from the wire into the terminal gradually and do not cause stress concentrations, as is done with a soldering connection. Soldered terminals are not considered satisfactory for aircraft wiring because vibration will likely cause them to break off the wire. Next question. The nominal rating of electrical switches refers to continuous A. Current rating with the contacts open, B. Voltage rating with the contacts closed, or C. Current rating with the contacts closed. So, the nominal rating of electrical switches refers to continuous current rating with the contacts closed. This rating represents the continuous current rating of the switch with the contacts closed. Next question. What is the maximum amount of time a circuit can be in operation and still be an intermittent duty circuit? A. 3 minutes, B. 2 minutes, or C. 1 minute. So what is the maximum amount of time a circuit can be in operation and still be an intermittent duty circuit? B. 2 minutes. Next question. When adding a rheostat to a light circuit to control the light intensity, it should be connected in A. Parallel with the lights, B. Series with the lights, or C. Series parallel with the light switch. When adding a rheostat to a light circuit to control the light intensity, it should be connected in series with the light. Which of the following are some uses for a DC cell-send system? A. Indicate the position of retractable landing gear, cowl flaps position, cooler door position, fuel quantity, and position of wing flaps. B. Indicate the position of retractable landing gear, angle of incidence, and altitude. Or C. Indicate the fuel quantity, rate of climb, and position of wing flaps. So, which of the following are some uses for a DC cell-send system? A. Indicate the position of retractable landing gear, cowl flap position, cooler door position, fuel quantity, and position of wing flaps. DC cell-send systems are a widely used electrical method of indicating remote mechanical condition. They are used to show the movement and position of retractable landing gear, wing flaps, cowl flaps, oil cooler doors, and other movable parts of an aircraft. They are also used for measuring fuel quantity. Next question. A certain switch is described as a single pole double throw switch. The throw of a switch indicates the number of A. Circuits each pole can complete through the switch, B. Terminals at which current can enter or leave the switch, or C. Places at which the operating device, toggle, plunger, etc., will come to rest and at the same time open or close the circuit. So, a certain switch is described as a single pole double throw switch. The throw of a switch indicates the number of circuits each pole can complete through the switch. The throws of a switch indicate the number of circuits or paths for current the switch can select for each of its poles. A single pole double throw switch can select either of the two paths. Next question. What does a rectifier do? A. Changes direct current into an alternating current.
B, changes alternating current into direct current, or C, reduces voltage. So what does a rectifier do? Changes alternating current into direct current. A rectifier is an electrical device or circuit that allows electrons to pass in one direction but blocks them when they try to flow in the opposite direction. A rectifier changes alternating current into direct current. Next question. Certain transport aircraft use AC electrical power for all normal operation and battery-furnished DC electrical power for standby emergency use. In aircraft of this type that operate no DC generators, the batteries are kept charged by A. Inverters which use the aircraft's AC generators as a source of power, B. Alternators which use the aircraft's generators as a source of power, or C. Rectifiers which use the aircraft's AC generators as a source of power. So certain transport aircraft use AC electrical power for all normal operation and battery-furnished DC electrical power for standby emergency use. In aircraft of this type that operate no DC generators, the batteries are kept charged by rectifiers which use the aircraft's AC generators as a source of power. Large aircraft that use AC for normal electrical operation often use battery-furnished DC for standby use. These systems use transformers to reduce the voltage and rectifiers to change the alternating current into direct current to keep the batteries charged. Next question. Integrated drive generators employ a type of high output AC generator that utilizes A. Brushes and slip rings to carry generated DC exciter current to the rotating field, B. Battery current to excite the field, or C. A brushless system to produce current. So, integrated drive generators employ a type of high output AC generators that utilize a brushless system to produce current. An IDG is a high output brushless alternator built into a single unit with a constant speed drive. A permanent magnet generator produces three-phase AC, which is sent to the voltage regulator section of the GCU. The output of the GCU supplies current to the exciter field coil, which controls the output voltage of the generator. So, here we'll add generators. We'll add the IDG and also the GCU. Next question. If one switch is used to control all navigation lights, the lights are most likely connected A. in series with each other and parallel to the switch, B. in series with each other and in series with the switch, or C. in parallel to each other and in series with the switch. So if one switch is used to control all navigation lights, the lights are most likely connected in parallel to each other and in series with the switch. If navigation lights on an aircraft are controlled by one switch, the lights are connected in parallel with each other and in series with the switch. Next question. The basic difference between an autosyn and a magnesyn indicating system is the A. rotor, B. transmitter, or C. receiver. The basic difference between an autosyn and a magnesyn indicating system is the rotor. A basic difference between the autosyn and magnesyn remote indicating systems is the type of rotor used by each system. The magnesyn system uses a permanent magnet and the autosyn uses an electromagnet. Next question. What is the ratio of turns between the primary coil winding and the secondary coil winding of a transformer designed to triple its input voltage? A. Primary will have 1/3 as many turns as its secondary. B. Primary will have twice as many turns as its secondary. Or C. Primary will have 3 times as many turns as its secondary. So, what is the ratio of turns between the primary coil windings and the secondary coil windings of a transformer designed to triple its input voltage? Primary will have 1/3 as many turns as its secondary. If a transformer has 3-to-1 step-up ratio, the secondary winding will have 3 times as many turns as the primary winding. The secondary voltage would be 3 times the primary voltage. Next question. The type of electric wire terminals used for most aircraft applications, in addition to providing good current carrying capabilities, are designed primarily to A. Prevent circuit failure due to terminal disconnection. B. For uncomplicated and rapid circuit connection and disconnection. Or C. For permanent connection to the circuit. So the type of electric wire terminals used for most aircraft application, in addition to providing good current carrying capabilities, are primarily to prevent circuit failure due to terminal disconnection. Terminals used on aircraft electrical wires must safely carry all of the current the wire can carry. They must also be designed in such a way that they cannot cause a circuit failure by inadvertently disconnecting from the terminal on which they are installed. Next question. In an AC circuit with no phase lead or lag, which is true? A. Real power is 0. B. Real power is greater than apparent power. Or C. Real power equals apparent power. So in an AC circuit with no phase lead or lag, which is true, real power equals apparent power. In an AC circuit that has no lead or lag, the power factor is 100%. All of the current is in phase with the voltage. The real power is equal to the apparent power. We are going to write down real and apparent power. Next question. Major adjustments on equipment such as regulators, contactors, and inverters are best accomplished outside of airplane on test benches with necessary instruments and equipment. Adjustment procedures should be as outlined by A. The equipment manufacturer, B. The FAA, or C. Aircraft technical orders. So, major adjustments on equipment such as regulators, contactors, and inverters are best accomplished outside the airplane on test benches with necessary instruments and equipment. Adjustment procedures should be as outlined by the equipment manufacturer. Next question. What is a method used for restoring generator field residual magnetism? A. Flash the fields. B. Reseat the brushes. Or C. Energize the armature. So, what is the method used for restoring generator field residual magnetism? A. Flash the fields. Residual magnetism may be restored to a generator by flashing its fields. To flash the field, momentarily pass direct current from the battery through the generator field coils in a normal direction of current flow. Next question. Oil canning of the size of aluminum or steel electrical junction boxes is considered to be A. Normal operation in vibration-prone areas. B. A shorting hazard. Or C. Acceptable operation. So, oil canning of the size of aluminum or steel electrical junction boxes is considered to be B. A shorting hazard. Oil canning is the condition of a piece of sheet metal that causes it to snap back and forth when it is distorted or vibrated. If the size of the electrical junction box oil can, there is a possibility of some wires becoming shorted. Next question. A voltage regulator controls generator voltage by changing the A. Resistance of the generator output circuit, B. Current in the generator output circuit, or C. Resistance of the generator field circuit. So a voltage regulator controls generator voltage by changing the resistance of the generator field circuit. A voltage regulator controls generator output voltage by varying the resistance of the generator field circuit. This may be done by using a carbon pile voltage regulator, a vibrator type voltage regulator, or a transistor voltage regulator. The resistance in the field circuit determines the amount of field current allowed to flow. So we are going to write down vibrator type, carbon pile, and transistor. Next question. A CSD unit that is disconnected in flight due to malfunctions such as overtemperature may be reconnected, A. automatically if the temperature falls back into normal operating range, B. manually by the flight crew, or C. only on the ground by maintenance personnel. So, a CSD unit that is disconnected in flight due to malfunctions such as overtemperature may be reconnected by only on the ground by maintenance manual. Some jet transport aircraft that use AC as a primary electrical power have a switch on the flight engineer's panel that allows the CSD unit to be disconnected in flight if there is a malfunction, such as excessively high generator drive oil temperature. The CSD unit can be reconnected only by maintenance personnel when the aircraft is on the ground. Next question. When handling a high voltage capacitor in an electrical circuit, be sure it A. has a full charge before removing it from the circuit, B. has at least a residual charge before removing it from the circuit, or C. is fully discharged before removing it from the circuit. So when handling a high voltage capacitor in an electrical circuit, be sure it is fully discharged before removing it from the circuit. A high voltage capacitor can store enough electrical charge to cause a dangerous shock when it is removed from the circuit. Before removing any high voltage capacitor, short across its terminals with an insulated handle screwdriver with an insulated handle screwdriver to fully discharge it. Next question. How does the magnetic brake used to stop rotation on an electrical motor armature operate? A. Centrifugal force releases a rotating brake cog from a stationary notch when an armature reaches a certain speed, and magnetic force re-engages the cog when the electrical power is turned off. B. A friction brake is applied by the magnet and released by a spring. Or C. A friction brake is applied by a spring and released by a magnet. So, how does the magnet brake used to stop rotation of an electric motor armature operate? A friction brake is applied by a spring and released by a magnet. A magnet brake used to stop rotation of an electric motor armature is applied by spring force and is released by an electromagnet energized when the motor is turned on. As soon as the motor is turned off, the spring applies the brake and stops the rotation of the armature. So here we're going to write down the spring as well. Next question. In troubleshooting an electrical circuit, if an ohmmeter is properly connected across the circuit component and some value of resistance is read, A. the component has continuity and is open, B. either the component or the circuit is shorted, or C. the component has continuity and is not open. So, in troubleshooting an electrical circuit, if an ohmmeter is properly connected across the circuit component and some value of resistance is read, the component has continuity and is not open. Next question. The most common method of regulating the voltage output of a compound DC generator is to vary the A. current flowing through the shunt field coils, B. total effective field strength by changing the reluctance of magnetic circuit, or C. resistance of the series field circuit. So, the most common method of regulating the voltage output of a compound DC generator is to vary the current flowing through the shunt field coils. The most common method of regulating the output voltage of a compound DC generator is by varying the current flow through the shunt field coils. Here I'm going to write down shunt field. Next question. The poles of a generator are laminated to A. reduce flux losses, B. increase flux concentration, or C. reduce eddy current losses. So, the poles of a generator are laminated to reduce eddy current losses. The pole shoes of a generator are usually made of laminated soft iron to reduce the eddy current losses. Eddy current produces heat and are a source of power loss in a generator. Next question. And last question. Which statement relating to electric wiring is true? A. When attaching a terminal to the end of an electric cable, it should be determined that the strength of the cable to terminal joint is at least twice the tensile strength of the cable. B. When attaching a terminal to the end of an electric cable, it should be determined that the strength of the cable to terminal joint is at least equal to the tensile strength of the cable itself. Or C. All electric cable splices should be covered with soft insulating tubing or spaghetti for mechanical protection against external abrasion. So, which statement relating to electric wiring is true? When attaching a terminal to the end of an electric cable, it should be determined that the strength of the cable to terminal joint is at least equal to the tensile strength of the cable itself. The tensile strength of a wire to terminal joint should be at least equivalent to the tensile strength of the wire itself. The resistance of the joint should be negligible relative to the normal resistance of the wire.